All right, welcome back to Learn PowerShell. We're going to start a new series, taking a break from the beginner series and focus on the series that I'm just going to call Advent of Code in coordination with the Advent of Code uh, event that's going on right now. If you're not familiar with Advent of Code, it's an annual coding event that goes on from December 1st to the 25th. There's one question released each day with two parts, and each part gives you a gold star. I encourage everyone to try to do this on your own, so I'm not going to release each video until the day after at the earliest. And I hope to keep up with this, but 25 consecutive days of posting is going to be pretty extreme, obviously, especially with the holidays. So let's go ahead and look at day one. So day one, this is the Sonar sweep. So I apologize. I just made this in PowerPoint really quick just to show you guys and walk you guys through how we're going to do this. So you can pause right here and read this if you want. It's up to you. So this is where we start getting into the actual problem. So as a submarine that you're in drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby sea floor. Your puzzle input appears. Each line is a measurement of the seafloor depth as the sea looks further and further away from the submarine. So this report indicates that scanning outward from the submarine, the sonar sweep found depths of 131, 140, 136, 135, and so on. I do want to note that if you go out to the Advent of Code website, these numbers are not what will be on the website. These numbers coincide with my puzzle input, which is what we're using for this video. So I want to make sure that I'm doing this clear here. So you can read that second paragraph if you want, but to do this, count the number of times the depth measurement increases from the previous measurement. And the starting measurement, there's no previous measurement, so there's nothing to count there. So our starting point is going to be 131, a depth of 131. If the number increases, that means we're going lower in the water. If the number decreases, that means we're going higher in the water. So firstly, we have 131 and 140. So we're going lower in the water because the number increases. These are positions 0 and 1 in our array of items. So I just want to set that right now. So we're comparing the first two items. So 0 to 1 is a decrease in depth. The number increases. Then let's compare 1 and 2. The number actually decreases, so this means we're increasing our position in the water, so our depth is we're actually going higher, not lower. It's backwards for the numbers to where our relation in the water. But we're comparing positions 1 and 2 now, and the same is true for position 2 and 3, and so on for 3 and 4. So if we look at all of these together, it looks like this. So from 0 to 1 is a decrease in depth. From 1 to 2 and 2 to 3, it's an increase, a decrease in number. So our position is actually higher in the water. And then the final, what is that, 1, 2, 3, 4, 5, are decreases in depth. So this is actually wrong. It should say decreases. Sorry. Well, decreases in our depth position is what it should say. So let's look at this and start coding it by sight at first. So firstly, we know we're only comparing two positions at once, and it's the two that are right next to each other. So let's call the first position that we're comparing n, and the second position is always going to be n plus 1. So as you saw previously, I said this was 0 and this is 1. So we're going to go ahead and say that to start, our n equals 0. And so then it's comparing 0 and 1. And if we move forward in time to the next comparison, it's comparing 1 and 2. because n is 1 now. And then if we jump ahead to the very end, n equals 7 and n plus 1 is 8. So what we need to do overall to figure out how to run this is we're going to keep running it while n is less than 8. So I know that I said this is 8, so well, right now n is 7, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is 9. So, but we count starting at 0. So we want to do minus 1. So we're going to say the total is less than, or the total minus 1, so which gives us 8. So with this, we can just jump right into code and start looking at coding this. All right, so with that presentation out of the way, let's jump right into code and look at what we've got here. So firstly, let's just take a look at our puzzle input. Whoops, if I loaded it up. So there's a lot of entries. Let's look at the first couple so we can verify. Let's look at 0 through 8 because that's what we had in our presentation. So there you go. Those are the first 8 numbers that we saw also in the present. Actually, the first 9 numbers that we also saw in the presentation. So it's 1 extra. But let's go ahead and build this out. So first things first is we know that we need to count every time that we there's an increase in number because that's a decrease in depth. So let's go ahead and say that our counter equals 0 to start because we have nothing to start with. Also, we know that because we established it in that presentation that n is going to start at 0. We know that we're starting there. Then also in that presentation, I said while n is less than the total count minus 1, we're going to keep doing this. So let's literally just write that in. So n is less than, and let's say puzzle.count minus 1. I like spacing. I just think it makes it easier to read. And let's add a couple spaces in here. Okay. So now to say how we do this. So we know that we're comparing position n and position n plus 1, and that if position n, or in the case of what we see here, 0 is less than 1, we're going to count that. So let's say if, puzzle n, whatever's in the nth position, is less than puzzle n plus 1, then we are going to add 1 to the counter. And no matter what, we're going to increment n by 1 so we can compare the next 2 numbers. So this is all we have to do. And let's just write what the counter is afterwards. So I know for a fact that running this code, I'm going to get a almost perfect answer. So the counter actually comes out to be 1465. I know that the answer for me in my puzzle was actually 1466. This again is, as I've said in the previous video, an off by 1 error. I haven't been able to figure out where my error is. I honestly have looked at this 15 times. I've changed so many different entries, especially this, thinking that maybe I was miscounting. I don't know. But this is almost exactly what we need to do. So that is part 1 of day 1. Part 2 is a little more involved, and we're going to cover that as well. Let me just clear this out, and I'll be right back with you. All right, so part 2 uses the same puzzle as we had before. However, our instructions have differed a little bit. What we need to do is now consider the sums of a 3-measurement sliding window. So instead of comparing 0 and 1, we're actually going to be comparing the sum of 0, 1, and 2 to the sum of 1, 2, and 3. So you can see they've labeled them A and B here for easy representation visually. So right here we can see that the measurement is in the first window are these 3, and the sum is 607, and the second window is marked 618. So the second window is larger than the first, so the comparison is increased. So that would be something we count. So I've set a new counter. I called it in counter. I also reset 0 n to 0 and reloaded the same puzzle. So with this, we're just going to have to make a few changes to work out what we originally wrote. It is going to look a little bit more complex, but essentially we're doing the same thing, just a little bigger scale. So let's go ahead and do the while. So we're going to say while n is less than, and this is where you need to understand a little bit about easy subtraction addition. So where before we did the whole puzzle count, because we don't want to do that, because we don't want to get into a spot where it's adding these 3 to these 2, because this number doesn't exist, because this number is the last number. We don't want to get into something like that. So we need to make sure that we stop it when the count is less than 3 of the total, to make sure that n always has space to go one more, or I guess 3 more really. So firstly, we need to establish groups of numbers. So this first group is 0, 1, and 2, like I said. So this, let's call this group 1, and we're going to say that group 1 is n, because we're always going to start at a 0 position. And then this is going to be n plus 2, which covers 1 and 2. So if I run this, you can see that group 1 is 0, 1, and 2. That's perfect. And I'm going to show you why we're doing it this way and how this works. So group 2 is going to be n plus 1 to n plus 3. Again, just adding 1 really to all the positions, because this is 0, this is 1, this is 2, so this should be 3. So now I need to figure out the sums of these groups. So first, let me show you how this works. So where puzzle n works like this and just grabs whatever is in the 0th position, puzzle group is going to work the same way. It's going to grab those first 3 numbers in positions 0, 1, and 2 and return them. So that's perfect for what we need, because now, again, we don't have to statically assign anything, which would take hours to try to write. So let's say that sum1 is equal to puzzle group 1, and what we're going to do is a built-in commandlet called measure object, and we want the sum. I know for a fact that when I do this, I get back an object that has a table. It tells me how many objects it added, tells me what the sum is, because I only want the sum. I can do average, I can do all of these things and have that fill that in, but I don't care. So if you remember anything before from arrays, then you'll know that all we have to do is step into this using the property that exists. So all we want is the sum. So even though we just did sum, we're going to do dot sum, and what that's going to do is only give us that result of 407. So we're going to do the same thing. I'm just going to copy and paste. There's no reason to recreate the wheel. Change this 1 to a 2. And there we go. So let's say that if sum 1 is less than sum 2, now we're going to say n counter plus equals 1. And then again, have to increment n by 1. It always moves down one position. So the next set is going to be 200, 208, 210 when it compares these three to the next three. So if I run this and check my n counter, 1491, I know for a fact that if I look at the Advent of Code website, it will say that your puzzle answer was 1491 and that I completed both parts of my puzzle. So that does not have an off by 1 error, and the code is almost the same. So I'm really not sure what happened in part 1, but this is a good introduction to the Advent of Code and how simple coding these things can be, even though they're word problems. 90% of everything you code will be a word problem. You're probably not just going to sit down and, have something to code that hasn't been addressed verbally, or at least in your own head, that is an issue. This is a good exercise to actually get word problems and figure out what you need to do, and then figure out how to build it from there. I probably will not develop presentations for every other day. I just wanted to show you a good starting point in how you can approach the code, because I do want you to at least attempt to solve these things on your own. However, if you need help to go over it, you can go to the Reddit thread at /r/advent of code, or you can just watch these videos or find videos that other people have done on YouTube. Thanks, and I will see you soon.